Okay, we have to get common denominators in rational expressions just like we do in fractions. So this is all going to be about finding common denominators. So first, let's talk about the least common multiple. Okay, the first thing you want to do is factor each polynomial. The least common multiple contains each factor and the greatest number of times it appears. Okay, so if I'm doing something like this, what I do is I look at my smallest number and I start multiplying. 4 times 1 is 4. Does 9 and 6 go into that? No. 4 times 2 is 8. 9 and 6 don't go into that. 4 times 3 is 12. Well, 6 goes into that, but 9 doesn't, so that doesn't work. 4 times 4 is 16. Neither of them go into that, so that one doesn't work. And I just keep going. 4 times 5 is 20. Nope, neither 9 nor 6 go into that. 4 times 6 is 24. Oh, look, 6 goes into that, but 9 doesn't. 4 times 7 is 28. Nope. 4 times 8, and some of you are going to, if you're better at numeracy skills, you're not going to have to write this all out. Is 32? No. But 4 times 9 is 36. Yes, 6 goes into that, 9 goes into that, and 4 goes into that. So that's going to be our our least common multiple in just the number. So that would be 36. Then we look at our letters. We have a p squared, a p to the first, and p to the third. We take the one that appears the most. P to the third is what appears the most, so that has to be in the least common multiple because each one has to go into our results. Okay, so this is backwards from factoring. Then we look at our q's. Well, there's a q to the third, a q to the fourth, and then no q's. So we have to go q to the fourth. And what this gives us is a polynomial that each of these can go into. Okay, so they can each divide into that. So that's a little different than what we did before. And that's how we're going to find the least common multiple. So let's look at the next one. So our smallest number to deal with is 15. So we have to find a number that 15, 16, and 20 all go into. So because we're dealing with the least, we're going to start with the smallest number. 15 times 2 is 30. Well, I'm going to start with 15 times 1. That doesn't work. 16 and 20 doesn't go into it. 15 times 2 is 30. 15 times 3 is 45. And I might have to get my calculator out to do this. 15 times 4 is 60. So far, none of these. 20 goes into 60, but 16 doesn't. And then we eventually have to get all the way up to 15 times 16, and that's 240. And 15 goes into that, and 16 goes into that, and 20 goes into that, thank goodness. So 240 is our number. Now we have to take the largest of the x, whichever one has the biggest exponent has to go. So a squared, a to the third. So it has to be a to the third. It has to be the least common multiple. b1, b to the sixth. Got to be b to the sixth because b to the sixth is the biggest number that has to be divided into. And then c to the third, c to the third. So they all have to have a c to the third. So there's our least common multiple on that one. Okay? Now these two, we're going to have to factor. Again, if you don't know how to factor, you're kind of at a loss here. So in this first polynomial, I'm going to factor out an x, leaving me with an x squared minus x minus 2. Not done factoring. I have an x minus 2, x plus 1. So that's this group. Okay? Now let's do the other group. So this one can be factored, and these aren't multiplied together. This can be factored into x minus 2, x minus 2. So then we have to make sure everything is represented. So we have an x in the green, so I got to write that down. I have an x minus 2 in the green, but I also have an x minus 2 in the pink, so I have to write that down. I have an x plus 1 in the green, so I got to write that down. Now here's the problem. In the pink, I already took care of one of the x minus 2's, but I need 2 of them for the pink to work. So I have to write them all down. Now if there's the same one in each, you don't have to write it twice. So like we have x minus 2 and an x minus 2. Well, they match, so we only had to write that once. But we had to write another x minus 2 because this one has 2 x minus 2's. So our least common multiple here, if we wanted to write this in shorthand, would be x times x minus 2 squared times x plus 1. I would accept either answer. Okay? Now, to add or subtract rational expressions, fractions, you must have a common denominator. So that's why we just went over this. This is how we get a common denominator. Okay? So let's look how to make 6 and 14 into a common number. So we need these both to be over the same. So 6 and 14, let's see. Well, 6, 14 doesn't go into it. 12, 36. I'm going to keep going. It really is 42. It's 6 times 14, which is 42. Nope, that's not right. Actually, I'm going to keep going until I get 42. 14 times 3 is 42. So I figured out 42 is my common number down here. Now remember, when we're dealing with variables, we got to take the largest one. So we have a b and a b to the second, so we got to put b to the second. We have no a in the first, and we have an a to the seventh in the other one. So this has to be our common denominator. So the question is, in order to figure out our numerators, what did I multiply 6b by in order to get 42a squared b squared? So in order to get this, what did I multiply by? Well, first I had to multiply by a 7. And I didn't have any a's, so a to the 7th. I had 1b, so I only had to multiply by 1b. Whatever I do to the denominator, I have to do to the numerator. So I also have to multiply that. So it's going to be 35 a to the 9th b. Okay, because I multiplied the numerator by the same thing I multiplied the denominator by. Okay? In this one, what did I have to multiply the denominator by to get here? Well, what did I say? I had to multiply by 3. Okay, I'm going to make it a dot. I have to multiply by 3, but I already have a to the 7, so I don't need that, b squared. So all I'm doing is multiplying by 3. And so I multiply the top by 3, and my top here is 27. So this is going to be my final answer. Our common denominator, and we added our numerators. Okay? Now when you get to the next one, here, there's a lot of things going on here. The first thing is I'm going to factor the denominators to see what I got going on. That's x minus 5. And then we take out a 6, x minus 5. Well, we already have an x minus 5 in both of them, so that can be part of my denominator. And then we have a 6 in one and a 3 in the other. So if we make them both 6, we're good. So what did I have to multiply this first fraction by? Well, this had to get multiplied by a 2 to create that. So we also have to multiply this by a 2. Now don't forget this is a chunk. So that's going to be 2 times x plus 10. Okay? Now this one, we multiplied by 1. So if I multiply by 1 here, I just multiply by 1 here. All right. Now this is also a chunk. Now let's write our common denominator. Our common denominator here is going to be 6x minus 5. In the numerator, we have 2x plus 10 minus 3x minus 15. We had to distribute this negative. Okay? We're not done here. And here's why. We have to see if there's any simplifying that can go on in the numerator. So we have 2x plus 20 in the numerator minus 3x minus 15. And we're still over 6x minus 5. Okay, so let's see what we have in the numerator. Well, that gives us negative x plus 5. That looks very similar to what we have in the denominator, except the signs are backwards. If the signs are backwards, in the numerator, we can factor out a negative 1. If I do that, it changes the signs. Now look what happens. We can cancel out these x plus 5s, and our answer here is negative 1/6. Not the easiest thing in the world to do, I know. But you're going to have to practice it. Oh goodness, look at this next one. Okay, here, let's see what's going on here. When I look at this, I get automatically, I'm like fractions and pluses and minuses. I'm going to erase this so we can do this. All right, well, let's just write it as a division problem. Let's start there. 1 over a plus 1 over b, whoops, sorry, My cat is chewing on this while I'm trying to do this. 1 over a plus 1 over b divided by this chunk, stop, is divided by 1 over b minus 1. Okay? Now, before we do anything, we're not going to change anything. We need to get these as one fraction. Right now, they're split up fractions in there. So our common denominator for the first is going to be AB, because we have an A and a B. So the common denominator is AB. Well, what did I multiply this by? In order for A to go to AB, I multiplied by a B. That means the numerator gets multiplied by B. In this case, I multiplied by an A. And so the numerator becomes A. Okay? So that's our first little putting together. So here's a chunk here. And we're going to divide by, well, how can I make 1 with a denominator of b? Well, let's take out 1 and put b over b. That's going to make it easier. So our common denominator is just b, and 1 minus b is our numerator. Now back to 9.1. 9.1 tells us we can copy the first fraction and then multiply by the reciprocal. Now remember, we're still dealing in chunks here. So there may not be a lot to cancel out, and there isn't. In this case, the only thing that can cancel are the b's. Again, don't be tempted. Just because you have b plus a, that's a chunk. It has to have another chunk to match. So our answer to this one is b plus a over a times 1 minus b. Okay? There we are. Oh my goodness. All right, get ready for the next one. All right, let's rewrite it so that it doesn't look so confusing. All right, so the first thing I'm going to do is write it as r plus 6 over r minus 1 over r plus 2. That's my first chunk. And we're going to divide that chunk by r squared plus 4r plus 3 over r squared plus r. Now the second chunk already has a common denominator. There's no plus or minus between fractions. So our second chunk I'm going to leave alone for a minute. In the first chunk, I need to get a common denominator. Well, I have an r and an r plus 2. So that has to be my common denominator. So what did I multiply this by? Well, I multiplied that by r plus 1. So that means I have to multiply r plus 6 times that. So we have r plus 6 times r plus 1. Oh, we also have to multiply. Okay, wait a minute. Did I mess something up here? No, I'm good. Okay, so we multiplied this by r plus 1. Now to get this one, we already had the r plus 2, so we only had to multiply by an r. So in doing that, that's going to give me negative r. The negative comes from here, and then it's 1 times the r that we multiplied by. Okay? And then over here, we have divide by, so this is a chunk right now. And we have this, r squared plus 4r plus 3 over r squared plus r. Now that first one's still kind of a mess. So I need to do something with that. I need to make the numerator better. So, oh, these are just so much fun. These are not my favorite, but here we go. I'm going to make this, and I'm going to FOIL that. So it's r squared plus 7r plus 6. So I did this, I FOILed. Okay, minus r over r times r plus 2. We still have this other one over here that we're not ready to deal with yet. We will in a minute. Okay, that already has a common denominator and the top is okay right now. So now what do we have in the numerator here? We have r squared plus 6r, because 7r minus r, plus 6. Over r times r plus 2. Now I'm going to do the copy dot flip. I'm going to leave that. I'm going to change this to multiplication, and I'm going to flip this chunk over. Actually, here's what I like to do. And then it's going to be r squared plus 4r plus 3. Well, none of the chunks match right now. That much thing we can factor. So let's see. I'm going to factor this numerator into r. Does this one factor? Oh, I did something wrong. What did I do wrong? Oh, this should be a 12 here. No, it shouldn't. Oh, yeah, this was supposed to be a 2. This is what happens. So this is supposed to be an 8r, and this is supposed to be a 12. I was going too fast. So that leaves me with 7r plus 12. Okay, I made a mistake. I hope some of you saw that. Okay, so then now it factors. R plus 3, R plus 4. I knew I did something wrong because it didn't factor it, and we make these factor. So that goes away. This one's already factored into chunks. I just need to put a parenthesis around the R. On the numerator of the second one, I can factor out a common denominator of R, leaving me with an R plus 1. And over here, I can factor this into R plus 3, R plus 1. You can see it's really helpful if you can factor quickly. Now I'm going to start crossing out numerators and denominator chunk. Oh, I hope this works out nice. Well, R plus 3 can cancel with an R plus 3 in the bottom. R plus 1 chunk can cancel with an R plus 1 in the bottom. This R can cancel with this R, leaving our two chunks as R plus 4 over R plus 2. This is not an easy concept. This takes a lot of practice. So I would go back and watch this a little bit slower. I would try some of the problems on the homework and then go back and watch the video. This will be on a Canvas or an online quiz.